Okay, part B number 7, given function g and function h, find fx such that f of g of h is equal to x squared over x squared plus 1. So the first step is to substitute hx. So we have f of g, and then you substitute h, 1 over x to the power of 4 equal to x squared over x squared plus 1. The second step is, you know, function g is already given, so you substitute 1 over x to the power of 4 into function g. So we have f set of 1 over x to the power of 4 is equal to x squared over x squared plus 1. Before you proceed, we may simplify. Set 1 over x to the power of 4, it becomes 1 over x squared, okay, equal to x squared over x squared plus 1. So in this bracket we have 1 over x squared. You need to do substitution. Let's say let y equal to 1 over x squared. You may choose any variables other than x. So x squared is equal to 1 over y. Therefore, the next step is please make sure your function on your left and right hand side in terms of y. Okay, so we have fy is equal to 1 over y over 1 over y plus 1. Okay, so we try to simplify. Look at the denominator part. So we need to equate the denominator. So it becomes 1 over y over 1 plus y over y. Therefore, you may cancel y and y. So fy becomes 1 over 1 plus y. And your question in terms of x, please make sure your final answer in terms of x lah. So fx is equal to 1 over 1 plus x. So your answer is D. Part B number 8, given that f prime 4 is equal to 2, find the value of limit x tends to 4, fx minus f4 over set x minus 2. So for this one, you may use the formula for differentiability at a point x equal to a. So the formula is f prime a is equal to limit x tends to a, fx minus fa over x minus a. So in this question, point a is equal to 4. We have f prime 4, okay, equal to limit when x tends to 4, fx minus f4 over x minus 4 is equal to 2. So by looking at this one, set x minus 2, and this one is x minus 4. So how to relate these two expression? This is actually x minus 4. You may factorize x minus 4. For example, if you have a quadratic x squared minus 4, you may factorize. It becomes, okay, it becomes x minus 2 x plus 2. Alright, so if we have x minus 4, it becomes set x, okay, set x minus 2 times set x plus 2. Okay, so let's factorize. So we have limit x tends to 4, fx minus f4 over, okay, set x minus 2, set x plus 2 is equal to 2. Okay, next, by applying the properties of limit, this expression you may write separately. It becomes two expression. Okay, so let's rewrite separately. So we have a limit x tends to 4, okay, fx minus f4 over cert x minus 2 times limit x tends to 4, okay, 1 over cert x plus 2 is equal to 2. So for this limit, for this expression, it should be no problem. You may substitute the limit. Okay, so we substitute the limit. Okay, this one limit x tends to 4 fx minus f4 over cert x minus 2. So this one you substitute, you get 1 over cert 4 plus 2 is equal to 2. So this one you just insert into calculator, okay, you get 1 over 4. Okay, so therefore the question asks you to find limit when x tends to 4 fx minus f4 over cert x minus 2, and it becomes 2 times 4 is equal to 8. So your answer is D, 8. Part B, number 9, find y prime of y equal to x cubed times cert x squared plus 2. This is a product, so we need to do product rule. I choose the first term as u, so u is equal to x cubed, okay, and v is equal to cert x squared plus 2. It means that x squared plus 2 to the power of 1 over 2. And then you find u prime and v prime. So u prime is equal to 3x squared, and v prime we have we apply product rule, 1 over 2 times x squared plus 2, and then reduce power by 1, 1 minus 2 minus 1, 1 over 2 minus 1, we get negative 1 over 2, and differentiate the expression in the bracket, differentiate x squared plus 2, we have 2x, and then you simplify. Okay, so the next step is to substitute into formula of product rule. Y prime is equal to u v prime plus v u prime. So u times v prime, okay, so we have x cubed times x over cert x squared plus 2 plus v times u prime, 3x squared times cert x squared plus 2. What we have to do is to get the answer in a single fraction, so we need to equate the denominator. So the second term we multiply with cert x squared plus 2 over cert x squared plus 2, and then we have x to the power of 4 plus 3x squared times x squared plus 2 over cert x squared plus 2, and then we simplify, we get 4x to the power of 4 plus 6x squared over cert x squared plus 2, and it equivalent to answer B, okay, because if we factorize 2x squared, we factor out 2x squared, and we get 2x squared times 2x squared plus 3 over cert x squared plus 2. Part B, number 10, find the critical points of the curve y equal to x cubed plus 3x squared minus 24x and determine their nature. It means that you need to determine whether it is maximum or minimum. So the first step is always to find the first derivative, y prime. So we get 3x squared plus 6x minus 24. And y prime's always equal to 0. And then you do factorization by using your calculator. No need to show your calculation because this is paper 1. So we get x is equal to 2, or x is equal to -4. So by looking at the choices A, B, C and D, to -4, so we may ignore C because we have x is equal to 4. Okay, so we ignore C. And then we find the point of y. So when x is equal to 2, okay, you just substitute into your calculator. Y is equal to -28. So y is equal to -28. B, you get y is equal to 28. So you may ignore B. Okay. So next, we have when x is equal to 4. Sorry, when x is equal to -4. Okay. When x is equal to -4. You just take the answer from A and D. Y is equal to 80. Okay. So the next step is to determine whether maximum or minimum point for 2, -28 and -480. So we do the second derivative. Okay. So y double prime. We get a 6x. Okay. Plus 6. Okay, so try to check to substitute one value of x. For example, I choose when x is equal to 2. You substitute into your second derivative. Okay, 6 times 2 plus 6. You get a positive value which is greater than 0. So it means that the point is minimum. So 2, -28 is minimum point. And you may ignore A. Your answer is definitely D. No need to check for x equal to -4. Okay. Part B, number 11. Given function hx equal to exponent to x plus 3 and find function m equal to 2x over h inverse when x is equal to 5. So by looking at function m, we have h inverse. So the first step is to find h inverse by using property h of h inverse is equal to x. So we substitute h inverse into function h. We get exponent to h inverse, okay, plus 3 is equal to x. So we get x minus 3 exponent to h inverse x. And how to make h inverse as a subject? So we take by taking ln or log both sides, we get ln exponent to h inverse equal to ln x minus 3. And you simplify, you get 2 h inverse ln e is equal to ln x minus 3. And ln e is equal to 1. And h inverse is equal to 1 over 2 ln x minus 3. Therefore, you may substitute h inverse into your function m. Okay. So when x is equal to 5, 2 times 5 over h inverse 1 over 2 ln, and your x is equal to 5. Alright, so you just substitute this function into your calculator and you get 20 over ln 2. So your answer is A. Part B, number 12. Determine the value of A where the function fx is equal to a minus x for x greater than or equal to 3, and fx is equal to x squared minus 10 when x less than 3. And we already know that the function is continuous at point x is equal to 3. So it means that limit exists from left and right. Okay, so you don't need to do your calculation in limit form. What you have to do is to equate both function and substitute x is equal to 3. So we have a minus 3. Okay, we equate equation 1 and equation 2 and substitute x equal to 3, and you get a is equal to 2. Part B, number 13, solve the inequality 3 minus 4x over x squared less than 1. So the first step is you bring 1 to the left and you equate the denominator. So you simplify the numerator part, you get negative x squared minus 4x plus 3 over x squared less than 0. So the numerator part, you get a quadratic form. So before you factorize, please make sure that a is positive. Okay, so this is a negative 1. What you have to do is multiply both sides by negative 1. Okay, and then you get x squared plus 4x minus 3 over x squared, and the inequality sign change to greater than 0. Until this part, you may substitute or you may factorize the quadratic expression. So a is equal to positive 1, b is equal to 4, and c is equal to negative 3. No need to show your factorization. You simply substitute the values of a, b, and c into your calculator and you get the values of x. So we have x is equal to negative 2 minus 7, or x is equal to negative 2 plus 7. Okay, so for this one, x cannot be 0. So what you have to do next is, by looking at the expression, this one, okay, this one always greater than 0. Greater than 0, it means that positive. So by looking at the denominator part is x squared. So x squared is always positive, which is greater than 0 for any values of x. So to make sure that the expression in green color, x squared plus 4x minus 3 over x squared, always greater than 0 or positive, you need to have a positive over positive, and then you will get greater than 0. And then we may conclude that x squared plus 4x minus 3 must be positive as well, or greater than 0. So this one, we already have the values of x. X is equal to negative 2 plus 7, or x is equal to negative 2 minus 7. So you may solve by method of table of sign, or graphical method, or number line. So I use graphical method. So since a is positive, we have this curve, and then I put the factor. On the left will be negative 2 minus 7. On your right will be negative 2 plus 7. Okay, so by looking at the expression, x squared plus 4x minus 3 always greater than 0. So I need to shade the above part on your left, another one, the above part on your right. So the answer will be the shaded region in red color. So in this red color, the answer will be x less than -2 minus 7, or x greater than -2 plus 7, or it is equivalent to answer A. Okay.